Hey paleo artists, put down your pens and stop drawing Spinosaurus. Trust me on this. It seems the last handful of months have been some of the most spectacular and unexpected in the realm of paleontology. First, there were the images of a Carnotaurus skull surfacing online, which appeared to have preserved soft tissue that turned out to be hematite concretions. Then there was the resurfacing of a very old image of the outer casing of a Protoceratops fossil from Mongolia that also turned out not to be nearly as spectacular as many in the online paleo community originally interpreted. A new bombshell has been dropped, and dropped on an even more beloved dinosaur genus, Spinosaurus. Very much like Tyrannosaurus, when Spinosaurus was first discovered, it didn't immediately become a cultural icon. Though Tyrannosaurus ultimately took that title, and with haste, the inherent awe of Spinosaurus remains would skulk around the annals of paleontology despite being completely obliterated time and time again. With its inclusion in the third Jurassic Park film, Spinosaurus was forcibly catapulted into the public's consciousness of the handful of dinosaurs which make up the masses menagerie of real monsters. You know how I'll say the line, "Only new material will enlighten us further on the anatomy of this ancient creature"? That isn't just a thing I say to end a video. It's a reality we all must face as scientists, studying the crumbled remains of the Earth's ancient past. As bleak as the chances of any individual animal fossilizing is, any one species or genus tends to exist without changing or mutation for a biologically significant span of time, in the ballpark of tens of thousands to a couple million years, depending on who you ask. Therefore, even with what comparatively little fossil evidence we do have, and that does exist out there, more material of already known taxa does surface time and time again, and Spinosaurus is no different. World War II. I'm sure you've heard this story before, but it bears repeating beyond the usual parroted factoid, the Spino bones were bombed. The first remains of Spinosaurus were uncovered in the western desert of north-central Egypt. These remains were part of a collection of fossils uncovered in the Bahariya Oasis during the 1910s and 1920s, under the auspice of paleontologist Ernst Stromer of Germany. Stromer found the first remains he called Spinosaurus in the 1910s. He then found more material which he considered distinct from the first and simply designated it Spinosaurus B. It would remain a phantom taxon over the next century, variously referred to other animals like Carcharodontosaurus and the even more enigmatic Spinosaur Sigilmassasaurus. Despite this, these second remains would come up again down the road. Stromer was an incredible scientist and expeditioner, especially during the early 1900s, and led many excursions to Egypt, uncovering vast riches of the Cretaceous. Most of the animals making up the ecosystem of this area were found by Stromer, including Egyptosaurus, Carcharodontosaurus, Stomatosuchus, Bahariasaurus, and of course, Spinosaurus. In my opinion, he deserves a biopic in line with Mary Anning and many other scientists. I mean, if the story of an anti-Nazi scientist feverishly attempting to solve the giant carnivore puzzle of Cretaceous Egypt only to have his life's work destroyed by an Allied bombing raid during World War II after pleading with the actual Nazi director of the Munich Museum to move all the precious artifacts away from the encroaching war doesn't deserve big screen blockbuster type biopic, I don't know what does. It's war, dinosaurs, science, and everything you'd want from a movie. How has this not been made? Spielberg, get on it. Scratch that. Blomkamp, Edwards, or Villeneuve, get on it, fellas. Moroccan monsters. With the bones of Spinosaurus gone, there was nothing to be done in uncovering the mystery until new fossils could be found. From here on, all future Spinosaurus fossils were uncovered outside of Egypt, namely Morocco, with some reported from Algeria and Kenya. Those partial remains uncovered in the 90s only consisted of bones which had been previously destroyed. The ends of the jaws, claws, teeth, a dorsal vertebra here, and a cervical vertebra there, nothing which would unequivocally outline the mysterious shape of the spined giant's form. Ernst Stromer had reconstructed a speculative skeleton of the animal based on the fossils he had at hand, and other known giant theropods at the time. Overall, it was basically a giant allosaur or tyrannosaur, which walked upright on its hind legs, dragging its lumbering tail to and fro. It had the characteristically crocodile-like lower jaw, uncomfortably grafted onto an allosaur-like skull, and the famous vertebral spine sticking out of its back. Though Stromer was correct in his inclinations of a piscivorous, water-adjacent lifestyle, he did not reconstruct the rest of its body to reflect this. The advent of the dinosaur renaissance forced paleontologists at the time to fit those fragments of the spined reptile into a shape that made sense. Since more Spinosaurids were uncovered during the 90s and following decades, an idea of the group as a whole, and all of the characteristics they shared, was far more solid. Baryonyx from early Cretaceous England gave the first nearly complete body form of a Spinosaurid since the discovery of Spinosaurus itself. The dinosaur supervisors and consultants for Jurassic Park 3 used the knowledge lent by Baryonyx and the Spinosaurus fragments at the time to reconstruct the massively four-armed bipedal hypercarnivore you see on screen. This image of the creature would not stand the test of time. The year before Jurassic's resurrection. Thousands of artisanal miners have scoured the southeastern region of Morocco for years to find fossils to sell. Though this practice works in an ethical and legal gray area, the industry is vital to the survival of many in the region, and, in my opinion, should not be outright condemned. Dr. Nizar Ibrahim, assistant professor of biology at the University of Detroit Mercy, has made it his top priority to get to know local diggers to check their hulls for elusive remains of the giant sailback. The bombshell story of the discovery of a cache of Spinosaurus fossils from this region via the web of indigenous fossil diggers made headlines in Nature, National Geographic, and many others in 2014. Dr. Ibrahim recovered many pieces of arms, legs, ribs, and the skull. The animal was reconstructed as a quadrupedal, knuckle-walking, short-legged, W-sailed, long-tailed creature which spent most, if not all of its time in the water. A super-specialized swimmer. Spinosaurus was, and is, the first unequivocal example of an aquatic dinosaur. This reconstruction was not without its critics. Plenty found fault with the assumption of knuckle-walking, as it has never been observed in any other dinosaur ever. The anatomy of the forelimbs and mass estimates for Spinosaurus strictly forbid this method of locomotion on a physical and biological level. The four-legged morphology of the animal was perceived due to the extremely short back legs and large forelimbs. It seemed as though it would have been too top-heavy to walk on two legs. Many also found the specimens guilty of being a chimera, or worse, a hoax. Paleontologist Dr. Andrea Kaw has tried to be an unbiased supporter of the 2014 interpretation. What follows is a shortened, reworded, and rephrased version of what he wrote on his Theropoda blog. One of the most stubborn objections to Spinosaurus semi-aquatic reevaluation focuses on the specimen's artificiality, that is, on the idea that it's too strange to be natural. Supporters of this position are not convinced the 2014 specimen is genuine. Rather, they believe it's an unnatural assembly, a chimera. At best, this chimera would be the result of an oversight of the authors, unconsciously and naively assembled by combining elements of distinct animals. At worst, it is a fake built voluntarily from parts of skeletons from distant areas to create a sensational animal on which to make money. I have and continue to consider the specimen a genuine fossil since its publication, as there are no serious reasons to doubt this. There is no positive evidence of presence of more than one individual at the site, since histological bone analyses don't show differences between the various parts. There is no evidence the fossil is a chimera, and the mere fact it's bizarre doesn't represent proof it's fake. Spinotypal. This brings me to the news of the year. In all past specimens of Spinosaurus, the tail is absent. All previous reconstructions, either skeletally or in life, assumed it had a tail roughly similar in overall shape to other large-bodied theropod dinosaurs. Dr. Ibrahim and his team went back to the Moroccan Spinosaurus site in 2018 to scour the area for more remains. And more remains they did find. Time was of the essence. He had heard from local contacts that commercial fossil diggers were tunneling into nearby hills for bones. Ibrahim could not risk letting the rest of what he believed to be the world's only known Spinosaurus skeleton vanish into collectors' curio cabinets. All the new remains are products of rigorous, documented excavations, carried out by a team of geologists and paleontologists, and therefore cannot be accused of a coarse composition of scattered bones collected without criterion by amateur collectors. Some critics raised doubts about the authenticity of the original fossil, since those remains reached paleontologists indirectly and were excavated by a local finder. With the new excavations, criticisms of 2014 are therefore definitively debunked as just hokum. The grueling excavation was worth the trouble, as Dr. Ibrahim and his team found tail vertebra after tail vertebra. By the end of the dig season, 30 tail vertebrae and pieces of the feet were collected and archived in a lab in Casablanca. What really sealed the deal were the comparisons made between the vertebrae they found and the vertebrae Stromer found in the 1910s. His illustrations of the very few and fragmentary tail vertebrae matched up to those found at this new site. This new tail of Spinosaurus proves definitively the creature was aquatic. Spinosaurus is now slightly less of a mystery. Just the facts, Jack. Many vertebrates have bones on the top, bottom, and sides of the vertebrae. These spines do different jobs. The ones on top, called the neural arches, act as protection and organization of the spinal cord and spinal nerves as they run through the animal. The spiny bit above that is the neural spine. This spine, as well as the spines on the sides and underside, are places for muscles to attach. The size of the spines and their width apart from one another correspond to the size and amount of muscles which attach to them. The new tail fossils of Spinosaurus outfit the creature with a newt-like tail, flattened sideways and expanded up and down. It should be no surprise these vertebrae are extremely weird. The special science word for bones which stick out of the sides of the vertebra is transverse process. The new fossils show that these spines were very wide at the base of the tail. They stuck out to the side at a near 90-degree angle. These sideways spines, combined with the tall neural spine and the chevron bones of the underside, make for what would have been a robustly muscled base to the tail. They remain this thick until about the 11th or 12th vertebra, at which point the sideways transverse processes shrink until they disappear altogether by the 18th vertebra. After this point in the tail, the neural spines are no longer broad from the side. They become pencil thin with a weird bulbous point at the end and start to curve forward and down. The shrinking and disappearing of the transverse processes means the muscle blocks of the tail also shrink from the base of the tail to the tip. The middle of the tail is oval-shaped, and the end is pill-shaped in cross-section. This also means the tail has a strong base and a weaker length. In order to prove the tail's effectiveness in propelling the beast through its home, Dr. Ibrahim and his team conducted a series of simple experiments. They cut a tail of Spinosaurus, Allosaurus, Coelophysis, a Nile crocodile, a crested newt, and a regular-ass rectangle out of pliable plastic, then attached each one to a special machine. This device combines a water flume with sensors, cameras, and pistons to track movements of aquatic animals and the forces they impart as they move. The team found the Spinosaurus tail to deliver 8 times the forward thrust recorded from the Allosaurus and Coelophysis tails. It was not as efficient nor as powerful as the crocodile and newt tails, placing it in between all 4 variables. Already, there's been a pleasant back and forth in the paleo community questioning whether this really proves what the authors say it proves. According to the authors of the new paper, this experiment proves Spinosaurus used its tail as an active propeller, giving it enough force to go after prey in the water. If this is valid, this would mean Spinosaurus was mostly, if not entirely aquatic in habit. Every time Spinosaurs enter the discussion, crocodiles are brought up in comparison. It's easy to see why. They both have long conical teeth, live in or near water, have long tails, and skulls pockmarked with sensor holes. Regrettably for this charming anecdotal comparison, these two groups are very different. More contemporaneously, crocodiles and spinosaurs are compared due to the hypothesis of similar locomotion when in the water. That is, swishing the tail from side to side in a relatively flexible manner. Anatomist, paleontologist, and skeletal artist Scott Hartman pointed out how the Spinosaurus vertebrae are not like those of crocodilians. It's also worth noting that the transverse processes reduce posteriorly quite quickly, not at all like crocodilians. He's talking about how the tail is really fat and muscly at the base, and then thins out very quickly, leaving most of its length the paddle-like shape. Dr. Mark Whitten tweeted with, "In addition to being delicate, those reclined neural spines overhang 3 or so verts too, which would limit flexion. My understanding is that croc tails are quite different, powerful and flexible to the tail's end, so less like a crocodile's powerful fluke, and more like a gondola lazily pushing itself along a river. Unlike Spinosaurus, crocodile tails have transverse processes, which continue along the entire tail length. These sideways blades of bone provide an ample canvas for the attachment of large muscle blocks to aid in the power behind each sideways undulation of the tail. This means crocodile tails are powered along the entire length, while a Spinosaurus tail has the most force at its base. A new problem with the tail now becomes obvious. Critics have lauded the spines are too fragile, thin, and immobile to produce sufficient thrust for the animal to use it as the main propulsion mechanism for active predation. As Dr. Whitten previously stated, the thin spines bend backwards and slightly down, which means by the time you reach their tip, they overhang the vertebrae directly after it. For a tail to be super flexible, it cannot have any bone in the way, which is the case of the crocodile's tail. All the spines point up, without any risking the possibility of bumping into one another, which provides the tail extreme flexibility. This extreme flexibility is what you need in order to remain stable in the water when swishing your tail. It may seem counterintuitive. We use a stiff flat paddle to move our boats by hand. For an animal, this is very different. When we use a stiff paddle, it pushes our boats, sure. But when have you ever seen a rowboat move as fast as a cruising crocodile? The currents under the surface are stronger, and require an animal to adapt a swishy tail to counter the currents, which could force its body to become unstable and roll all over the place. A stiff paddle under the water works, but it doesn't work well, and would force Spinosaurus to move very slowly if it used its tail as the primary tool for propulsion. Dinosaur specialist Dr. Dave Hone has suggested Spinosaurus wouldn't have been a pursuit predator, even with the current tail reconstruction. He goes on to state, "My point would be, there's a lot of things it could be doing, but one of those has been picked without any specific support or any real discussion of alternate possibilities. Yes, the tail shows some adaptations for swimming, but nothing that says hyperspecialist to me. And even if it did, that would fit with the hypothesized regular movement between patchy resources as well, if not better than pursuit predator." Crocodiles aren't exactly pursuit predators. They usually tend to wait and ambush large mammals at the water's edge. They will often undergo pursuit though, especially underwater. The results of the Ibrahim water flume experiment showed the crocodile's tail to be more efficient and powerful than Spinosaurus, so as little pursuit as crocodilians do, Spinosaurus likely did even less. Some artists, like Gabriel Ugueto, have suggested this tail may have been more useful in display, similar to the modern sailfin lizards or basilisks. Both of these lizards are great swimmers, but don't utilize their tail fins in an active locomotory function when in water. They use their tails to help them get away from predators, and to swim once they break the water's surface tension. They also don't have the sideways bones on their tail vertebrae, like the crocodilians, in a very similar fashion to Spinosaurus. Unlike Spinosaurus, these lizards only have the tall neural spines near the base, and it becomes a regular lizard tail for the rest of its length. For these reasons, and the difference in size, phylogenetics, and body form, I don't think they are great comparisons. Ignoring the fish in the room. Fellow paleontology student Tyler Greenfield raised an interesting point. The whole point about the spines being too thin is moot when you look at fish. In Suit, MSU paleo student Richard Carr posted, "George Lauder, one of the co-authors on this new paper, has basically written the book on lateral undulatory aquatic vertebrate locomotion and biomechanics. If he says the tail could propel this animal, then by God that's what evolution intended. Now, though I completely disagree with his reasoning in that last bit, his point stands that expertise in undulatory biomechanics of one of the authors does lend some form of credibility to claims of the tail as main locomotion mechanism, despite the fragility and overlap of the thin spines. If we take active swimming pelagic examples of ray-finned fish, like sailfins, we can plainly see they have a variety of different arrangements of vertebrae in their tails, some of which have spines overlapping 3 or more vertebrae. Yet they use their tails as their primary propulsion and their pectoral fins as rudders. Might Spinosaurus been similar? We don't know yet. The structure of fish fins more closely resembles the tail fin of Spinosaurus than do many other animals, but like I went over with the basilisks, they're not great comparisons for a bunch of other factors. This is a fresh story, and new things will come to light as more research, experimentation, and descriptions are done. It was noted Ibrahim and his team plan to study how webbed the feet may have been, including how wide the toes could spread and whether they could have helped Spinosaurus in moving around in the water. The 2014 Spinosaurus site promises to reveal more fossils, and future expeditions are not out of the question. The full picture of what Spinosaurus truly was continues to unravel, and I cannot wait to be there when it does.